Hey there, Year 11 students. I'm going to do another example where I'm going to be finding or how to sketch the graph of 2e. So we can see we've got a domain of negative pi to 2 pi, but let's start off with this particular graph. I'm going to just copy that and make space in, say, over here. All right, let's see. If I were to sketch this graph, what would I do? So first thing I need to read is what is my amplitude, and I can see already the amplitude is 2. So amplitude equals 2. I can see that the period is going to be affected by the 2 there. So period is equal to pi, or 2 pi on 2. Just for those who don't know, so 2 pi over 2, so it gives me pi. And then I can see that over here that tells me down by 1 and to the right by pi on 3. Then in my mind, I think about the graph. I say, okay, a cos graph normally looks like this, okay, with a period of 2 pi, normally. And the amplitude now tells me it's maximum 2, minimum 2. But because it's gone down by 1, okay, down by 1, so now it becomes essentially 1. Sorry, it's bad. 1 is here, so it's gone down by 1. So that means this has gone down by 1 as well. And that now gives me negative 3. So that's my new maximum and minimum. So you can think of the graph as something like that. Okay, kind of maybe more like, I can't be bothered. Just trying to make it look nice. But anyway, so it's gone down by 1 and then it's gone to the right by pi on 3. Now what's key here is I always use the starting point. So the starting point is currently 0, 1 now after you moved it down by 1. And then you're going to move it to the right. So that means the graph is now going to be at this point where it is pi on 3, 1, so it moves across by pi on 3. Okay, so in my mind that's the starting point or reference point, whatever you want to call it. I call it SP for starting point or reference point. And with the reference point I need to work the quarter cycles. So again, remember quarter cycles are quarters of the pi, so quarter of the period, sorry, so pi divided by 4. So that tells me to move to the next quarter cycle, I need to add on to this graph. So from here, I need to add an extra pi on 4 to get to the next quarter cycle. Okay, so let's work that out. And this is where it's the most important. That's probably the most tricky part to understand. You're taking the initial starting point, which is pi on 3 on the x-axis. You know that you're going to be moving to the right by pi on 4. So when you add them, notice the denominators aren't the same, so I need to change them so that they are the same. This would then be 3 pi on 12, and this one would be then 4 pi on 12. So in my mind, that's what I would have been doing. Now this is the key part. So now I'm going to try sketching. Okay, I'm going to try sketching with the quarter cycles. So I use my first reference point. Remember the first reference point was at pi on 3. Okay, move to the right by pi on 3. But I know pi on 3 is the same thing as 4 pi on 12. So I would rewrite this as 4 pi over 12. And the reason why I do that is because then calculating the next quarter cycle is much easier, because all you know is you're going to always add by pi on 4, which is the same thing as saying adding 3 pi on 12. So essentially you're always adding 3 because the denominators are the same. True? So here you would then say the next one has to be then 7 pi on 12. The next one then has to be 10 pi on 12. And it makes it easy to keep it in sort of, I guess, scale. So 13 pi on 12, and then you go to the next one, which is what, 16 pi on 12. And remember, because you're going, the domain was, I think it was negative pi to pi, was it 2 pi? Yep. So negative, remember, x is between negative pi to 2 pi. So if I keep following this, you'll know that as long as to get to 2 pi, it has to be passing 24 pi on 12. So I just keep going. So I'm like, all right, well, that's 16 pi on 12, add another 3, it's now 19 pi on 12, add another 3, is now 22 pi on 12. And if you add another 3, that's 25 pi on 12, which we know is now too far. Okay, but we can stop there. And then to go the other way, we know we need to reach negative pi, which is negative 12 pi on 12. Okay, so I'm going to minus 3 again. So this is pi on 12. Minus 3 again. That's minus 2 pi on 12. Minus 3 again is now negative 5 pi on 12. Minus 5 again, minus 3 again, sorry. That's, what is that? Negative 8 pi on 12. Minus 3 again is negative 11 pi on 12. And if you minus again, you already know that you're going to pass negative 14 pi on 12. So unless I've made a mistake with minusing 3s, which is a very likely chance, let's just see again. Yes, yes. Okay, cool. Then now I've got all my quarter cycles, so that represents quarter cycles. But remember the first starting point? The starting point was at 4 pi on 12. This was our starting point, our reference point. And we knew it started off at the maximum. True? It was at pi on 3, 1. And that was the maximum. That's the maximum of 1. So because of that, I can go back and say, all right, well, the maximum, remember, was 1. And the minimum was, what was it again? I think it was negative 3. So the pattern starts off at 1, and I'm going to put in my dot now. Actually, I'll do it in red. This is my maximum. And remember, the cost graph goes maximum, and it will go down, and it goes back up, right? So that means it goes down to center at 7 pi and 12, the next quarter cycle. At 10 pi and 12, which is the next quarter cycle, it drops down to minimum, back to center, back to maximum, back to center, back to... I just realized my center is not, it's not at, where's the center again? It's gone down by 1, so it's not there actually. So where's the center again? It went from 0, so minus 1. Whoops, I almost made a mistake there. Minus 1, don't forget that because I shifted the graph down, the center had moved down as well. So it should have been 7 pi, 13 pi and 12, 19 pi and 12 minimum, and then at 25.12 you expect to come back to the center. Okay, so, and then at pi and 12 you expect it to come back to the center, at negative, so it's minimum, center, maximum. Okay, maximum, and then back to center, and then back to minimum over here. Okay, so if I were to sketch it now, you can see that this is my cos graph. Here we go, here's my cos graph that has apparently moved. But remember, there was a restriction. It had to get cut off at 24 pi on 12, which is somewhere here. So that means it's going to have to stop here. And the other one was at 12 pi. So 12 pi is probably around here. So that means it has to stop there. So that means in part of my graph, when I draw them, I need to make sure to start at those 2 points there. So again, I'm going all the way up, coming back down, coming back up, coming back down, coming back up, coming back. Ooh, I was on a roll there. I like to make sure it looks generally nice. One curve, and there we go. Something like that. Okay, so now that I've got my endpoints, what I need now, you can see why this took a while. 1, I'm explaining, but 2, what am I missing? I'm missing x-intercepts. So I'm gonna draw it in this blue. I'm missing x-intercepts. So 1, 2, 3, 4, 5, 6. I can expect about 6 x-intercepts. I'm missing endpoints, and I'm missing y-intercept. Okay, so those are the extra things that I would have to do from now. So easiest one to find is endpoints and y-intercept starting. And then the next skill is to find x-intercepts, which I can imagine being the most difficult part there. But that's how you would sketch. Okay, so in general, my shape and all that would be right. I'm just missing the details right now. But that's how you sketch. Okay, I'll make a separate video on finding the x-intercepts, but I might as well just find the y-intercept while I'm here. Y-intercept is when x is equal to 0, solve for y. My equation was y is equal to 2 cos of 2 bracket x minus pi on 3 minus 1. I'll just put another bracket around that. And so if I let x equal to 0, well then, that's going to be 0 minus pi on 3. So when I multiply them together, I'm going to get y is equal to 2 times cos of negative 2 pi on 3 minus 1. This is where your exact values come in, and you have to know how to find cos of negative 2 pi on 3, exact values and symmetry properties. I know that's in quadrant 3, so cos is negative, so cos of pi on 3, which is half, so that's negative half there, times the 2 minus 1, and then y equals to minus 1, which is minus 2. So that tells me the y-intercept here, which clearly I've drawn wrong there, but if I label it, it's okay, 0 minus 2. Okay, so that's my y-intercept, and then to find endpoints, we knew that this was going to be at 2 pi, so we need to find the y value, and then same thing here, that was meant to be at negative pi, which we need to find the y value as well. Okay, and so here, if I were to find the y value, if x was equal to 2 pi, well then y was equal to 2 times cos of 2 times 2 pi minus pi on 3 minus 1. And you can see here, it's all about finding this. Okay, so it's where the students can use symmetry properties and exact values to solve that part. But essentially what you've got 2 times 2 pi is 4 pi. I like to think of it this way. I normally just think of it as 2 pi minus pi on 3. That's clearly in quadrant 4. And then you can times it by 2. But if it helps, this is how you can do it. You can do 2 times 2 pi, which is 4 pi, and then 2 times minus pi on 3, which is negative 2 pi on 3. So if you think about unit circle, I mean, you can simplify this as well if you want. I think of it as a unit circle. So 4 pi is over here, and minus the 2 pi on 3 will bring you over here. So clearly you're in quadrant 3. And if this is minusing by 2 pi and 3, well then this must be then pi and 3. So all I'm looking for is the cos of that. So I'm trying to find this length. So that triangle there, I'm trying to find the cos of pi and 3, which is much easier than, say, finding cos of negative 2 pi and 3, which is the same thing. Okay, so cos of pi and 3, that's clearly negative half there in the unit circle. So I know that this is again negative half, and again minus 1. This cancels out. So, and look at that, you get negative 2. So essentially the y-intercept, what happened? That must mean that the y-intercept and the endpoint over here fit as one nice perfect cycle. So you can then say this is now at negative 2. And then over here, you do the same. I'm guessing it's going to be the same as well because it's one nice full cycle. But let's prove that. So if we were to solve this one to find out y is equal to, again, 2 times cos of 2 times negative pi, minus pi on 3, and then minus 1. So again, using the unit circle, I would think of this as negative 2 pi. And then minus 2 pi on 3. So same thing again, unit circle. Negative 2 pi is here. And if you minus 2 pi on 3, well, you're going again down that direction. So everything's the same again. So yeah, this is going to be negative 2. Okay, so you can say that this is now at negative pi, negative 2. And that was negative 2 over there too. So I've got my endpoints there. So you can see all I'm missing now is the x-intercept, and if you go back and practice the x-intercepts, then you've got your graph. So from here on, it's all algebra, but the starting what I wanted to show was how to sketch, which all you needed was a quarter cycles, and you're sorted. Okay.